Fifth grade, in today's lesson we're going to see how there are many patterns in our system for naming numbers. If we take a look at this first box that I've put, this is basically right out of your textbook. We can see that place value can be used to name a number, such as 5,000, in different ways. So we could say that 5,000 could be named as 5 thousands, or 5 times 1,000. 50 hundreds, or 50 times 100. 500 tens, or 500 times 10. And 5,000 ones, or 5,000 times 1. Okay, so it says complete each sentence with ones, tens, hundreds, or thousands. Okay, so 3,000 is 300. What would that be? It would be 30 hundreds. Okay, and so how do you know it's 30 hundreds? Well, it would be the same thing as saying 30 times 100. Okay, and the other way to think about it is all of the zeros should equal the original number that you're trying to name. So for example, 3,000 has 3 zeros in it, and if you notice we have 1 zero here, and then we have 2 more zeros here. If you add them all up, you have 3 zeros. Okay, so 4,000 would be 4,000 ones. I'm just going to use the 1 to represent ones. 7,000 would be 700 tens. 9,000 would be 9 thousands. Okay, so again, you think about it like if you were to multiply the number times each of these, it would equal whatever number that you're naming. So 700 times 10 would be 7,000. 9 times 1,000 is 9,000, and so on. Okay, we'll do a couple more. It says use now a calculator to find these products. So if you were to multiply each of these with a calculator, you'd see that 9/10 times 10 is equal to 9. 9/10 times 100 is equal to 90. And 9/10 times 1,000 is equal to 900. Can anybody see a pattern? Okay, each time we're multiplying by an additional 0, the decimal point is actually just moving over to the right, equal to the number of zeros. Okay, so like in this last one, we multiplied by 3 zeros, so you would have moved it over to the right 3 places. So starting here, it would go 1, 2, 3, and so even though you can't see the decimal would be at the far right hand side. Okay, so in the next one, it's just the reverse to this. So 9 would then be equal to 9/10 times 10. It would be 90 would be 9/10 times 100. And 900 equals 9/10 times 1,000. Okay? In the next place value chart, notice 800,000 is now also represented using both words and numbers for the place value. So in the first example, we have 800 thousands, or 8 times 100,000. Then we have 80 10,000s, or 80 times 10,000. And finally 800 thousands, or 800 times 1,000. So we were just looking at this right here. Okay, so in example B, very much like what we just did in the first example. Okay, so we would take 7,000 equals 70 times, okay, what would that be? That would be, again, we have to have now the same number of zeros equal to the 7,000. So it would be 70 times 100. Okay, 200,000 equals 20,000 times 10, or 20,000 tens. And finally, 8 million would be equal to 800 times 10,000. Okay, so the number of zeros equal in your factors when you're multiplying the two factors should equal whatever the product is. Okay, so hopefully that helps.